Continuing with the review for Mac 1105, Chapter 2, Practice Tests. Numbers 5 through 7 you're asked to evaluate. In problem number 5, you're given the function f of x is equal to x cubed plus 6 over x squared minus 3. You're evaluating at -5. Go into the function, be careful with the signs, plug it in right here, right side. You're plugging in -5, cubing it, then adding 6 down here. You're taking that same value and squaring it, then subtracting 3. Putting this in your calculator with the parentheses wrapped around the -5, but actually, since it's an odd power, it really wouldn't matter whether you put the parentheses. It matters for even powers, though. I would get in the habit of just keeping the parentheses when it's a negative base. You would get that. You would add 6, and you'd get -119 at the top, while on the bottom you'd get +25 unless you forget to put the parentheses around it. Squaring never comes out negative, so this is +25, take away 3, giving you 22 on the bottom. Okay, going on to number 6. In number 6, you're given the function x squared minus 3, and you are asked to evaluate the function at x minus 2. So now what you need to be able to do here is you have to know how to FOIL, because you're not just plugging in a number and squaring it, you're plugging in an entire expression. I taught you some shortcuts in class regarding how to square without going into full FOILing mode, and that would be to use square, double, square when FOILing out a binomial. That way you don't have to write it out twice, nor write the FOILing arrows, nor will you have to combine like terms. So let's practice this shortcut. Squaring means square the first item. Double means double the number that you're seeing here. In other words, multiply by 2. So -2 times 2 is -4, and then attach that variable. That's the doubling part. Square, when you see it the second time, means square this constant back here. That would give you +4. Drop down the -3. So without all the extra hardware of the FOILing technique, you use the shortcut to get this. And now combine like terms. Final answer, x squared minus 4x plus 1. And that is the function with an x minus 2 plugged in. In number 5, you took the function and just plugged a number in. Moving on to number 7, where again you're practicing FOILing. Let's try again. Let's try that shortcut. So this time we're plugging in x minus 3, and the expression that we're plugging into is x squared minus 4. So x minus 3 squared, we're not going to expand it, we're going to use the shortcut. So square, double, square. Square that front term, double the constant, so 2 times -3 is -6, but you're going to need to attach that variable behind it, and then square again, but this time the constant. Drop down that -4, and combine like terms. Final answer, x squared minus 6x plus 5. Okay, moving on to number 8. Problem number 8, you're looking at a graph and you are evaluating for 5. Now, evaluating usually means that you're plugging in, but when you don't have anything to plug in and all you have is a picture, what you're going to want to do is, it says evaluate the function. The graph represents the function. You're evaluating at f of 5. That means they're telling you go to an x value of 5. So slide your finger over to +5 on the x-axis, because this f of 5 represents an x value. So they're guiding you to go to the x value called 5 and then rise up till you hit the graph. Slide your pencil over to the y-axis and you have found the y partner that goes with this x value. So the answer for number 8 is f of 5 equals 2. No calculation. There's no work for that problem. Moving on to number 9. Number 9, you're doing the same thing. They have given you a diagram and asked you to evaluate at an x value of 4. That's what f of 4 means. So slide your pencil over on the x-axis to 4, rise up to hit the graph, and then slide over to the y-axis. You end up being at about 1.5, 1.75, you could even call it. I'm going to call it 1.75. I'm not going to mark you wrong. If you say 1.5 versus 1.75, give it your best estimate. So f of 4 for number 9. 1.75, no work for that problem. Just sliding with your finger along the graph. Okay, last problem in this group, number 10. Use a graph to determine the function's domain and range. Okay, let's remember that domain in layman's terms is how wide is the graph. It refers to the x values. So what you are being shown here is part of a graph. Based on the way the graph is, since there is no darkened in point right here, let's assume that this graph goes on and on in the left-hand direction as well as the right. If you're confused about that, you can always ask me during the test. So we're going to say that this goes on in a negative x direction indefinitely. So negative infinity is the leftmost part of the domain. And then if you are looking at the right side of the graph, that actually stretches out to positive infinity if you had a viewing window that was large enough. So the legs or the width of the graph go from negative infinity, because this leg actually flares out this way, and this leg actually flares out this way. So when asked the width, you're going to give it interval style. Negative infinity to infinity would be the answer for number